In this video, let's take a look at question 224, basic calculator on Leetcode. The question is basically taking a string, which could potentially have brackets like you see here, and the operands of plus and minus, and evaluating it without using any evaluation functions. Part 2 of this introduces the fact that we could have division and multiplication. So you can see here, it's the same thing, but just division and multiplication. And part 3, which is on Leetcode, is the same thing, but it can also have brackets. So now the division will also potentially have brackets. So in a sense, we could solve everything with just part 3, but I'm going to work my way up to part 3 so you can see all the different solutions and so really understand how we arrive at the final answer. But let's take a look, right? Let's take a look at how we would do this. So in this first part, we have the plus and minus, and we have brackets. So let's take a look at what this might look like over here. Now, realistically, if we don't have the ability to use eval function, then what we have to do is we have to keep track of a sum, right? We have to keep track of what our sums are so far. For example, if I just have the value, and maybe let me go ahead and let me copy this. And let's just assume that we don't have the brackets for now, but let's just say we have something like this. So assume the question was just like 1 plus 4 plus 5 plus 2. And then obviously there could be like spaces, minus 3, etc. So something like this. Now what would we do? Well, in this case, right, like there's really only 3 scenarios, or maybe there's 4 of what the item could be. Actually, I think it's just 3, right? Either it's a number, either it's an empty space, or it's a plus or a minus, right? So it's one of the operands. So that's really all we could have inside of these. And in the case where we're introducing brackets, we'll have more, but let's maybe start off with something simple like this. So if you think about this one, how would we go about doing it? Well, one thing is that we have to go through the list, right? We have to go through the string over here. So we know that we're going to have to loop over the string. Now, one of the things that you might not notice here, but we actually have to take into account, is that all these numbers here are single digits. So it's completely possible that we'll have something like 44 or 43, which will be double digits or possibly even more. So what that means is that when we're going through the string here, we can't just take the digit we're on and assume that's the number that we're dealing with. Really, we have to go forward and we have to arrive at either a space or a plus or minus, something that's not a digit, to understand which number we're at. So let's maybe go ahead and start with that and see where we could get with that. So the way I'm going to go about doing this is I'm going to have a pointer here, which I'm just going to call, and maybe I'll zoom in a little bit here, just going to call this I pointer, and it's going to be a while loop, and I'll explain why in just a second. We have while I less than s, and then we'll just get the current item. So now, I at this point is going to be right over here. Now what can we do? Well, we need to understand what exactly this item is. Is it a number? Is it a space? Is it plus or minus? What is it? We don't know it. We don't know yet. So we're going to check for that. Now, one thing you have to note in I loops is you have to manually increment the I pointer. So we're going to go ahead and do that. But let's take a look at what we can do here. So we have our item over here. Now we're going to check, is it a number, is it a space, or is it a plus or minus? Well, let's go ahead and check if it's a number. The way we do that is we can check if item.isDigit in Python. This will basically confirm to us that it is a digit. Now, it doesn't mean that it's the only digit. For example, this could be something like 192. So what we really need to do here is once we've confirmed that it's a digit, we need to keep going forward in the loop until we arrive at something that's not a digit. And so in that way, we'll be able to form the entire number. So this is just one thing that I'm going to teach you, and it's just one thing you should know. I'm not going to dive too deep into it, but if you have something like this, let's say you just have the number 1, and then you arrive on a 9, how do you get 19 from that? And then from 19, how do you get 192? So the way you do this, and again, this is just something I'm teaching, which you can use in other problems, is when you arrive at the current number, then that number is going to be exactly what you have. Now, when you go to the next one, you're going to take this one, you're going to multiply it by 10, and then you're going to add in a 9. Because you can see that this is kind of in the tens place, right? So what we're doing is you're multiplying by 10 and you're adding a 9. So this is now the value of 19. When you get to the next one, you're going to multiply again by 10, and then you're going to add in the value. So in this case, it's going to be, so where was I? Sorry. So you're going to multiply this again by 10, and then you're going to add in the value 2. So this is going to be 19, multiply 10 is 190, and then plus 2, which is 192. So that's actually how we're going to go about doing this. And so let's go ahead and do that here. So what we're going to do is we're going to have another pointer because we don't want to manipulate I here. So let's have another pointer. We'll call it j, and we'll set j equal to I in the start, and then we'll continue looping. So we'll do while j is less than length of s, and s at j dot is digit. So what this is going to do is going to have I over here, it's going to have j over here, and we're going to continuously update j until we arrive at something that's not a digit. And so when we arrive at something that's not a digit, we know that we found our number so far. So what this means is that we're going to have to keep track of the number somehow, right? So let's just say our number here is 0. What we're going to do here is we're going to update the number. So we're going to do number is equal to number times 10 plus int s at j. So in the first part, this is just going to be the number 1 in this case. Now we increment the j. When we get here, it's going to be 1 times 10 plus 9, so it's going to be 19. And then you do it once more, so it's going to be 190 plus 2, which is 192. So at this point, when we're here, when we're outside, when we're on line 27, it means that we've arrived at something that's not a number. It could potentially be a space, it could potentially be a plus or minus, but it's not going to be a number. So at this scenario, we know that the number we have is something we need to work with. Okay, so now let's think about this. If we just had the value, let's just say we just had the expression, let's just say our input was just something like 120 or 345, let's just say, or something like this. Well, if we just had this and this was the number that we got, we need to return 345 in the end, right? So I think one base case that we all can hopefully see here is that if you don't really have any operands, if you don't have any plus, if you don't have any minus, if you don't have anything really, maybe you just have a number, then the thing you really need to return is it's going to be your number, and then it's going to be multiplied by the operand, right? Because if there was a negative here, then we want to return negative 345. But because there's really nothing here, the operand in this case is just plus, which is just equal to the number 1. So what we're going to do here is we're going to do, let's just do operand, and maybe I'll just call it sign actually. So initially the sign is just equal to plus. And so what we're going to do here is we're going to do if sign is equal to plus, then we're going to have a result variable here where it's going to keep track of the running sum, which is like the running everything in a sense. Like either this could be a minus, this could be a plus, but anything. What's going to happen is we're going to take the value of res and you're going to add to it the value of num in this case. Now if it was a minus, well then we would add the negative of the num. And so in a sense, what you can see here is all we're doing is we're going to go through this and we're going to continuously update res with whatever the value should be, depending on the sign. So let's say actually here, it was like this. So what we're going to do is we're going to have 192 as part of this. Now, we have a space, so we'll skip it. Eventually we'll reach a number, or eventually we'll reach something that's not a number. So what's going to happen in this case is we notice it's a sign. So maybe let's handle that case. So we can do elif item is in plus or minus. Then what we're going to do here is we're going to just update the sign to be this. Okay, so now what's going to happen is when we get to the 43, we're going to go ahead and we're going to parse the 4, we're going to parse the 3, we're going to get the number 43. But what are we going to add to res? Well, we notice that we updated the sign to be negative. So we're going to actually add the value of negative 43 in this case. And so that's how it's going to work with these simple cases here. And this is really all we need. And in the end, we returned res. This is really all we need to handle the cases where we don't have to deal with any of the brackets themselves. So if I go ahead and I just run this, you're going to see that it is going to still work. And actually, I did notice one bug here. Because we are updating j over here, we need to actually update I to point to a certain location, right? Because we're updating I at the very end. So what's going to happen here is if j is over here, we actually want to update I to be some place, right? Because what's going to happen is j is going to be at the 1, at the 9, at the 2, and it's going to exit at the next loop, at the next kind of like spot over here, because the condition is not going to meet. So in this case, what we need to do with the I is we actually need to put it. Where are we going to put it? Well, it would be incorrect actually to put it to j, because what's going to happen in that case is that you're going to be right over here, and then we're actually going to update I to kind of the next value over here. Now, honestly, this works in this case, but in the case for something like this, let's say it was like 192. In this case, if we set it like this, then I is here, and then we update the I, well, we're going to go ahead and we're going to skip the minus. And so we don't want that. So we're actually going to update I to be j minus 1 in this case. So I is equal to j minus 1. So that when we add it, it's going to go ahead and it's going to be the value of j. So we're going to actually put the I over here, and then when we do the plus 1, it's going to be here, and then we're going to go ahead and process the minus. So that's just one thing I forgot to mention. But that's essentially like what we have. And so let me go ahead and I'll run something like just this, just to kind of show you that it works. But yeah, you can see we're getting the right answer over here, right? So this works in this case. Now the question is, how do we handle the brackets over here, right? How do we handle the brackets? Now, if you kind of just look at the brackets, the way it kind of works, and you're taught in math class, is like you have to evaluate the brackets kind of on their own, right? So the brackets don't actually influence what's on the outside. At least like when you're evaluating it, it doesn't influence anything. So what this kind of looks like is like we have 1, and then we have plus, and then this you can think of it as like own kind of expression, right? You can think of it as its own subproblem in this case. And so one way that we could kind of emulate this is like we need to find the answer of this subproblem over here, and then we need to kind of use the answer to the subproblem to solve the bigger problem here. Now, one thing you could maybe just do is like, okay, well, how do I find the answer to this subproblem? Like, how do I find the answer to whatever's inside of the brackets? Now, one thing you might just think about is recursion. So, for example, like we have the answer up till here, and now I need to do a recursive call to find the answer here, and then when it returns, I have the answer to this entire thing, and then I can just proceed normally. So that is a way in which it can work, and we're going to discuss the recursive approach in the future. But one thing that kind of, for this question, you don't actually need the recursion just right away. What's something else we could use instead of recursion? Well, recursive approaches are generally just based off of a stack, right? The idea is the kind of the same here. Recursion is generally a little bit cleaner, and we're gonna show that just in a bit. But I think I kind of want to start off with like a stack solution here, because it's going to do the same thing, but maybe it'll like lay the groundwork, and it kind of is a little bit easier to understand, like if you don't want to do the recursion. Okay, so how do we do a stack solution here? That's the question. Well, when we're doing a stack solution, what do we need to store? Well, what we need to store is we need to store the value that, if we're emulating recursion, in recursion, when you do the recursive call, you have no knowledge of what happened before. And then when you return is when you have knowledge of, okay, this was the answer prior to this, this was the sign prior to this, etc. When you're doing the stack approach, it's the same idea. When we're solving this subproblem here, we don't want to overwrite the result that we have so far. We don't want to overwrite the sign that we have so far, because we're going to need those later on. Because once we return off of this, we need to be able to take that answer and apply it to whatever the res was before or whatever the sign was before. So I think one way that this kind of makes sense to do is what we're going to do is we're going to check. So if or elif item is equal to something like this, well, in this case, we kind of want to push stuff to the stack. What do we want to push? Well, let's maybe take a look at something like this, right? Let's take a look. Let's see something. Let's say it was like this, right? If we're over here, if the I is over here, then what we want to push to a stack is we want to push like the value that we've recorded so far, right? Because once this returns, once this gives us a value of 7, we need to see that, okay, we need to possibly add 7 to whatever we recorded over here. So we need to push the data that we've got so far that it's going to get overwritten. And in the case here, what's going to get overwritten? Well, two things, right? We're overwriting the sign and we're overwriting the result. So we're going to push those two things to a stack. And so I'll define a stack here. And so we have stack.append. So we're going to append two things. And what we're going to append, and you could just append them together, or you could append them just two separate things. I'll just append them separately. So we're going to append the sign, and we're going to append the result that we have so far. And I'm actually just going to switch the order of these two. Just, you don't have to, but it's just something makes sense to me. So we're going to do that. Okay, so now that we've done this, let's emulate the recursion call, right? So once you do the recursion, what happens? Well, all your variables get reset, right? So when we're evaluating this, when we're evaluating the expression inside, we don't want to have the result that we had. That's why we push it on the stack. So it makes sense to reset the result here. It also makes sense to reset the sign, because we want to reset the sign to plus. So now we've kind of reset our variables. Now this is how we're like emulating the recursion. Okay. So now when we do the evaluation, we're going to evaluate this inner expression over here. Now let's say we go ahead and we reach this closing parentheses. So let's handle that case. So LF item is the closing parentheses. So how do we handle this one? Well, what we really need to do is we need to understand that when we reach the closing parentheses, we have our answer. We have our answer inside of these brackets. We have our answer inside of these brackets. What I need to do with this answer. So let's think about this, right? So if I had, let's just say we had something like, an expression, maybe we call it 3 minus 1 plus 2. Let's say we had something like this. So what would we do in this case? So let's go ahead and figure out what we're pushing to the stack, right? So we're pushing the result and we're pushing the old sign. So we have the stack is going to be the result, which is going to be 3 so far. And then we're pushing the old sign, which is going to be minus here. And I say old sign, but really when you're pushing to the stack, it's the current sign. And then what we do is we go ahead and we reset them, which is what we do here. And then we evaluate this expression. So what is this going to give me? Well, this is going to give me the value of 3, right? It's going to give me the value of 3. Now, when you return from the recursion, when you return from the stack, what we have is we have the answer in our current frame. We have our answer in our current stack frame. So the current answer is going to be 3. So current, and maybe actually just to make this a little bit clearer, let's just say this was 4, right? So the current answer in this case is actually going to be the answer of 5 in this case. And so what's going to happen here is that when we get to this closing parentheses, what we need to do is we need to take the 3 and we need to apply it to the 5. Now, how are we going to apply it? Well, what we're going to do is we notice that we have our old sign over here and we have the old result, which is like the 3 over here. So what you need to do is you need to take the 3, apply the old sign to the current answer, which is a 5, and then this is your new kind of answer. This is once you return from the recursion. And so how this is going to look like is that when we go ahead and we parse this, well, first thing we need to do is we need to pop off the stack. And because it is a stack, it is last in first out. So we'll do old sign is equal to stack.pop. We'll do old res is equal to stack.pop. Now, what is the current res? Well, res, in this case, res is the current answer inside the brackets, right? So this is the current answer inside of it. What we want to do is we want to reset res. So the actual res, when we come back out of the stack, when we come out of the recursion, what's the value of that going to be? Well, it's going to be whatever the answer is right now, we're going to apply the old sign to it, and then we're going to apply the old result to it. So what that's going to look like, it's going to look at old result, and then it has to apply the old sign to it. And so how's that going to work? Well, what we're going to do is we're going to check. So if old sign is equal to plus, then result, we're just going to add in the current result. And really, I should keep track of the current result. So I do current result is equal to result here. So we're going to do something like this. And maybe actually just to make it easier to follow, let's just do new result. And then, so result, new result, we're going to add the result. Otherwise, new result, we're going to subtract the result. And then we're just going to update result is equal to new result. So this is the idea here. Again, what we're doing is we're taking the value inside of this, and then we're applying it to what we already know so far. Okay, so now what's going to happen? Well, the I, in this case, is going to be over here. And so really all we need to do is we can just go ahead forward in the loop, because then we're just going to go here to the next variable, or the next item in the string. And so we don't need to do anything there. But yeah, so now we have a result over here. And so that's essentially how we're going to process these brackets. And so let's go ahead and let's run this. And we'll go ahead and do this. And we can see that we get a working answer here. Okay, cool. So this makes sense to me. Now, I hope it makes sense to you, but let's take it a step further, right? Because maybe we don't want to keep track of this stack, or maybe we don't want to, like worry about all of this. How about we just do a recursive approach? Okay, so let's do a recursive approach. How can we maybe do that? So to do a recursive approach, kind of the way I like to do it is I just like to have another helper function here. So I'm going to do return self.helper. And then what are we passing in? Well, just the string itself, right? So I'm just going to do def helper string. And then this should actually just give me exactly what I want. So if I go ahead and run this, it should just give me my answer. And I need to do self here actually. And so this should just go ahead and work. So I just extracted it to like a new function. Okay, so what do we need to do now? Well, in a helper, in a recursive helper, what we need is we don't actually need the stack, right? Because the entire point of recursion is that it's going to be its own subproblem. So what we're going to do here is instead of actually appending to the stack, why don't we just call the helper? Now, if you think about it, if we just pass in the string in the helper, we don't actually know where we are in the string. We need to keep track of where we are. And so if you really think about it, the way we had before, where we were keeping track of like the I and everything, that still needs to apply here. When we're doing the recursion, let's say we're like over here. Now in the recursive stack, the I is going to get reset over here. So we actually need to keep track of where we actually are in the problem. And so what I'm going to do is I'm going to pass in an index here. Initially, it's going to have the value of 0. And so the I over here is actually just going to point to the index. And so what we're going to do is when we reach an open parentheses, all I really need to do is I just need to pass an I plus 1, meaning let's go to the next element inside of the string. And then I'm going to get something back. What am I going to get back? Well, I'm going to get the answer back. Remember, we're returning res. So we're going to get the recursive res, which is like the recursion answer back. But also, I want to get something else back, right? I want to get back essentially where I am in the string. Because if I do the recursion, and then I process this, I process this, I process this, and then I'm over here and I pop, well, my I in the recursive stack is going to be all the way here. But when we pop off, we're going to get reset over here. So really, I need to also keep track of the index to where this closing parentheses is. And that's actually very easy to do, because all we really need to do is we're going to go ahead and we'll do new index, and then we'll do equals over here. And then all of this, we don't actually need here, because what we're going to do is we're just going to go ahead and return. We're going to return the result, and we're going to return I in this case, which is the current index. And so we don't actually need any of this here. So now it's the same idea. What we're going to do is we're just going to move this logic into here now. So again, what's going to happen is that once we return, well, we have a recursive answer and we have our new index. Well, our new index is going to point at the closing parentheses. So what we can do is we can just update I to be the new index, because when we do I plus equals 1, we're going to just move forward. So then we don't need to change anything there. So now that we've updated I, what do we need to do? Well, we need to update the result, right? And how are we going to update the result? Well, we already have the recursive result here. So really, this problem becomes something very simple. It's just like current result, and then we have sign, and then we have recursion result. So really, if you think about it, it's just applying this thing again, but it's going to be on the recursion result. So I'm just going to go ahead and copy this here. So we just check the sign, and remember the sign here is like our current sign here, because we broke out of the recursion. So it's going to be the current sign here. So what we're going to do is the result is plus equals the recursive result. Otherwise, it's going to equal the negative of the recursive result. And so we do this, and then we actually don't need to do any of this. We don't need to reset anything because of how just easily recursion works here. And so this might look like a complete solution. One thing I'll just point out is usually in recursion, when you return something, you kind of want to have it to return the same thing. So over here at the very end, I'm just going to pass in the index. And then over here, I'm going to get the first item, or the 0th item, because the second one is going to be the index here. But this is how easy the recursive solution is. So we don't have to keep track of a stack or do anything fancy like that. So let's go ahead and I'll go ahead and submit this. And then cool, so we can see that this one works here. Now, this is, believe it or not, pretty much 99% of the problem. The only thing that we need to do now is we need to handle the case where we have possibly multiplication or we have possibly division. Okay, so now how can we do that? Well, what is the problem with multiplication? What is the problem with division? The problem with multiplication and division is that you can't just apply it on what you've seen so far. What I mean by that is, if we just have simple numerics like this, if we have 1 plus 2 minus 3 plus 5, well, the 5, you add 5 to the result of all of this here. But if you had something like this, 1 plus 2 minus 3 times 5, well, you need to apply the 5, multiply it only with the last element here. You cannot multiply 5 with this entire thing, of course, unless it's surrounded by brackets. But what you need to do is you just need to apply it to this last operand here. And it's the same idea with division. You need to divide 5 by this last operand here. So how are we going to do this? Well, if you think about it, kind of the way that we were talking about this in the start, and maybe what I'll do here is I'll actually go ahead and I'll move this to the second question here, basic calculator 2. So let me just go ahead and paste it in here. So this one, you can see it's the same thing. It doesn't actually deal with the bracket, so we don't have to worry about that. We'll fix that later in the last problem. But basically, all we need to do now is we need to take care of how are we going to handle the case where there's going to be brackets, there's going to be plus, minus, division, and multiplication. Well, in this case, what we can do is that for something like multiply, we know that it has to apply to the last item. Same thing for division. So why not, instead of cumulatively adding to the result, like every chance we get, like we're adding to the result, why don't we just add it to something like a list? And what we could do in this case is that when we're doing the multiplication, we just take the result, which is going to be the last item in the list, and then we multiply it with that. Or when we're doing division, we take the result, that's like the last item in the list, and we just divide by that. And so what that kind of looks like is if we had something like this, right? So we would have the value of 1 in the result. Then, instead of adding 1 and 2, we would append 2 to the result. And then we have the value of 3 here, negative 3 here. So what we're going to do is going to append negative 3 into the result. And then we're actually going to go ahead and divide it by 5. Now, normally, if this was not here, then what we could just do is we could just return the sum of this, which in this case would be 0. But because the phi is here, what we need to do is we need to actually do minus 3 divided by phi. And really, this will be like an integer division, but the idea is the same. So why don't we maybe take that approach? So how about we put everything inside of like a list, and then we just sum it up, and we'll return that in the end. So let's see how we can maybe go about doing that. So all we really need to change here, and maybe I'll just go back to the first problem, just so we can also test it with brackets in this case. All we really need to do is we need to handle a few more cases. So first thing we're going to do is let's just call it running, or let's just call it nums list, right? We'll call it nums list. At the very end, instead of returning result, I want to return the sum of nums list, sum of nums list. So you have something like this. Now, instead of doing this, instead of applying this to result, let's just not even care about result. Let's just go ahead and add it to the nums list. So what we can do is we can go ahead and do nums list dot append with just a number. In this case, what we're going to do is we're going to do nums list minus number. And then how about we do the other two cases as well? So elif sign is a multiply. Well, in this case, remember, it has to apply to the last number we saw. So we're going to do nums list at minus 1 is equal to nums list at minus 1 multiply the current number. And then same thing for division. Now note that for division, we actually have to convert it back to integer, because they said that, I guess they didn't say it here, but in the next problem, they'll say that division has to be integer division. So we're going to do in this case, we'll do integer nums list minus 1 divided by num. And then we just have to add multiplication and division here. And then we just kind of have to take these two and also put them over here. So let's zoom out. So this one is actually going to apply to nums list. So we're going to do something like this. Nums list, and then you're going to put the recursive result here, and then nums list, negative recursive result, and then here it's going to be recursive result in this case, and then recursive result in this case. And then that's the answer here. So let's take a look. Let's see if this actually works. And we're returning results. That's the problem. So again, we need to return the sum of the nums list. And we can see it works. So perfect. So now let's go ahead and copy this, and I'll paste it in basic calculator 3 on Leetcode. And the idea is the same. Let's go ahead and run this. And you see it works. Perfect. So the only thing that we really changed here is instead of having a running sum and like we're just constantly adding to res, we chained it to a list. And assuming there's no multiplication or division, it's the same thing because we're just returning the sum of the list. So it's the same thing in the end. But because there's multiplication and division, we're going to be multiplying it or dividing it by the last item. And so that's how you go about doing this. So this is like the final solution that I would present, because it combines recursion, it combines kind of like this list over here, and then this sum thing. So I think this is kind of really the best solution in a sense that kind of makes sense. You could arbitrarily maybe extract this out to another function, but I think this is kind of makes it very easy to understand. So this is the solution. No slicing, no nothing fancy like that. Just pure recursion, pure just string manipulation, and then just understanding it. So this is how this question is done. I know it's a long video, but I hope it made sense, and I hope you learned something from this one.